Only 4.8% of vehicles ever cross 250,000 miles. Yet mechanics and repair data confirm that certain components routinely survive 300,000, 500,000, even well past 1 million miles. We are counting down 10 overbuilt parts, from overlooked castings under your hood to the one component documented beyond 3 million miles, ranked by the real-world mileage that proves them nearly indestructible. Starting with number 10. In the 10th place, metal intake manifolds stand as one of the quiet survivors under the hood. Cast from rib-reinforced aluminum 356 or traditional gray iron, these plenums shrug off the relentless heat cycles that crack lesser materials. The difference comes down to basic metallurgy. Aluminum 356 delivers a tensile strength around 210 megapascals, and cast iron nearly matches it, both far exceeding the 30 megapascals of plastic. Ford's notorious recall in the 1990s, documented in TSB 9603B, highlighted how polypropylene manifolds split and leaked under thermal stress, prompting a return to metal. In practice, the manifold itself almost never fails. Service invoices show it's always the gasket that gives out, not the casting. High-mileage case studies back this up. A 2004 Camry logged 250,000 miles on its original metal intake, with only minor carbon cleanup needed. Mechanics know the story. While plastic versions can crack before 120,000 miles, metal manifolds routinely last beyond 200,000 miles, often outliving the car itself. Number 9. Aluminum throttle bodies are the unsung workhorses of the intake path. Built from 6061 T6 alloy, these housings reach a tensile strength of at least 260 megapascals, making the body itself almost never wear out. Inside, a simple butterfly valve pivots on a hardened steel shaft, minimizing friction and keeping moving parts to a minimum. Your mechanic describes metal throttle bodies as lifelong components, with typical service limited to cleaning every 75,000 miles, not replacement. Failures are rare and usually tied to neglect or severe contamination, not wear. The result is that most vehicles retire with their original throttle body still bolted in place, a testament to the power of strong materials and simple design. In 8th place, solid flywheels are the definition of mechanical simplicity, just a single forged or cast iron disc, often ENGJ L250, that shrugs off hundreds of thousands of clutch cycles without complaint. Unlike dual-mass flywheels, which introduce a spring pack and typically fail between 112,000 and 124,000 miles, according to APSA's 2023 Repair Shop Survey, the solid design has no internal wear points. The tensile strength of these discs matches that of cast iron engine blocks, 250 to 350 megapascals, leaving a wide margin over any stress they will ever see. Failures are rare and usually traced to severe abuse or visible cracking, not gradual wear. Mechanics routinely report original solid flywheels still in service after 250,000 miles, as seen in owner logs for 1995 Camaros and countless small block Chevys. Here, mass and simplicity win out. Fewer parts, fewer problems, and a part that almost always outlasts the clutch itself. Number 7. Brake caliper bodies are the quiet survivors of the braking system. Fixed-type calipers, whether cast iron or aluminum, are designed as rigid shells that rarely fail, even after years of hard use. Mechanics routinely see original caliper castings on Hondas still going strong at 200,000, 300,000, or even 386,000 miles, often through multiple sets of pads and rotors. One veteran technician with over 20 years in the Midwest reports only a handful of caliper body replacements, almost always due to severe rust rather than mechanical failure. In drier climates, these castings can last the life of the vehicle. It is the seals and pistons that eventually leak or stick, not the caliper body itself. The story changes in the Rust Belt, where road salt can pit even the toughest iron. Aluminium calipers resist some corrosion, but both materials can succumb if exposed long enough. Still, outside of harsh environments, the caliper body's combination of strong metal and simple design lets it quietly outlast most moving parts on the car. Number 6. Coil springs are the quiet backbone of every suspension. They are built from high-strength 60 SAU R7 or 9262 spring steel and engineered for a near-infinite fatigue life. These wires endure relentless cycles of compression and rebound, yet their tensile strength, often between 1,800 and 2,100 megapascals, keeps them from taking a permanent set. Shot peening after heat treatment adds a protective layer of compressive stress, making surface cracks less likely to propagate. Still, not even the toughest metallurgy can fully resist the effects of road salt. Surface notches deeper than 30 microns, especially when exposed to chloride, can trigger cracks and embrittlement. One Jeep owner logged 172,000 miles of off-road abuse with the original springs still holding ride height. A testament to their resilience, unless salt or deep corrosion gets a foothold. With proper coatings, these coils routinely outlast the shocks, bushings, and sometimes even the chassis they support. Number 5. Modern fuel tanks quietly outlast the cars they ride beneath. Today, tanks are molded from high-density polyethylene, HDPE, or built from welded steel with epoxy or zinc coatings. The real secret is chemistry. HDPE shrugs off rust entirely, never corroding even after decades of road salt and moisture. Steel tanks, when properly coated, can exceed 300,000 miles before any sign of structural failure. In practice, tanks rarely fail from internal wear. Most replacements trace back to punctures, failed fuel pumps, or sender units, not the tank wall itself. Victor Shepard's million-mile Toyota Tundra logged over 800,000 miles on its original steel tank before a single replacement, while the 2003 Silverado's tank stayed leak-free past 300,000 miles. Unlike moving parts, these sealed reservoirs benefit from their static role. No friction, no heat cycling, just a passive container. The result? Fuel tanks are almost never on a mechanic's replacement list unless an external force intervenes, making them a classic case of strong material and simple stationary design. Number 4. Steering columns are the silent survivors tucked behind every dashboard. Most are built from hot-rolled carbon steel with a yield strength between 300 and 450 megapascals, far stronger than the forces they ever face. What sets the column apart is its static roll. It is a straight tube or shaft, protected from weather and road salt inside the cabin, rarely exposed to the corrosive threats that shorten the lives of tie rods or steering racks. CarParts.com describes the steering column as a life-of-vehicle component, and real-world fleet logs back it up. Police Crown Victorias and taxi fleets routinely pass 200,000 miles on their original columns, with the only service usually needed at the universal joint or the collapsible collar, not the main tube itself. Failures almost always trace to the U-joint at the base, which can be re-greased or swapped out, leaving the core steel shaft untouched. It is a classic case of minimal motion and strong material. The column itself simply does not wear out, quietly outlasting far more complex steering parts. Coming to the top 3, the differential housing stands as one of the most quietly overbuilt parts on any vehicle. The classic Dana 44 axle, in continuous production since the early 1950s, anchors this reputation. Its thick-walled shell, cast from nodular or gray iron, never rotates, never faces friction, and rarely sees a stress spike outside catastrophic accidents. The secret is in the material. ENGJL 250 or ENGJS 350 nodular iron delivers a tensile strength of at least 250 megapascals, while a network of internal ribs and precision-machined bearing caps spread out every load. In off-road icons like the Jeep Rubicon, these housings routinely log 400,000 to 600,000 miles without a single crack. Dyna's own durability report cites a staggering 99.6% failure-free rate up to 600,000 miles, with housing cracks remaining almost unheard of, even after decades of axle and gear swaps. Mechanics know the gears or bearings can wear out, but the housing itself is nearly indestructible. This static, sealed shell embodies the three-trait formula: strong metal, no moving surfaces, and a purely structural roll. As a result, the differential housing often outlasts the rest of the drivetrain, quietly surviving long after the gears inside have been rebuilt. Number 2. Manual transmission gears have quietly built a reputation for outlasting nearly everything else in the drivetrain. At the heart of their longevity is 8620 carburized steel, a low alloy blend that undergoes a deep heat treatment to reach a case hardness of 55 to 60 HRC, hard enough to shrug off decades of shifting, yet tough enough inside to absorb shock loads without fracturing. These gear sets sit submerged in oil, bathed on every revolution, which means wear comes not from friction, but from the rare neglect of fluid changes. Simplicity is their secret weapon. A manual gearbox contains just a handful of solid gears and synchronizers, with no pumps, no clutch packs, and none of the hydraulic complexity that plagues automatics. The evidence is hard to dispute. Irv Gordon's legendary Volvo P1800S crossed 3.26 million miles on its original 4-speed transmission, needing only regular oil changes. Honda's 1 million-mile Civic kept its factory gears intact, requiring just a clutch swap, a job that costs a fraction of an automatic transmission rebuild. Performance racing industry calls these gear sets practically immortal, and mechanics routinely see original manuals in service at 300,000, 500,000, even 1 million miles. Where automatics fail from valve body wear or electronic faults, the manual's solid, oil-bathed gears keep spinning, a testament to the mantra that fewer parts mean fewer problems. This is the penultimate survivor, beaten only by the indestructible cast-iron engine block. And finally, in first place, the cast-iron engine block stands alone as the ultimate survivor under the hood. Gray cast-iron's secret is its flaky graphite microstructure, which acts like a built-in damper, absorbing vibration and stopping cracks before they can spread. This metallurgical backbone gives the block a tensile strength of 20,000 to 25,000 psi, almost double that of aluminum blocks, which typically top out at 10,000 to 14,000 psi. Franco Reznick's 1991 Chevy Silverado, documented by NPR, logged 1.29 million miles on its original small block 350 5.8. The block never cracked, never warped, and never needed a rebuild, just regular oil and coolant changes. Victor Shepard's Toyota Tundra joined the Million Mile Club on its factory 2UZFE cast iron block, with only routine maintenance along the way. Then there is the Cummins Million Mile Club, where more than 90 diesel trucks have crossed the 7-figure mark, some even reaching 3 million miles, all with their original iron blocks still intact. CarMD's Vehicle Health Index puts engine block failure in the bottom 2% of all reported repairs, an outlier in a world where timing belts, batteries, and sensors fail regularly. The reason is simple. The block is a static casting with no internal moving parts and no friction surfaces to wear down. Its only job is to hold everything together, and it does so for decades. When mechanics talk about parts that refuse to die, the cast iron engine block is always at the top of the list, a testament to the power of strong metal, simple design, and a generous safety margin. In the end, it is the foundation that quietly outlasts everything else, proving that fewer parts really do mean fewer problems. Across all 10 parts, one truth stands out. Longevity favors strong metals, minimal moving pieces, and design simplicity. As NPR and CAR-MD data, along with million-mile case studies prove, fewer parts mean fewer problems. Ironically, it's the cheapest, simplest consumables that fail first. That's the paradox driving every high-mileage legend.